For problem 21, it says if the distance from a charge is doubled, is the magnitude of the electric field increased, decreased, or the same? All right, so now for 21, we're talking about electric fields. And the formula for an electric field is K times the point charge, Q, and the radius squared, or the distance squared. So remember that K is equal to 9.0 times 10 to the 9. And then we don't know what Q is yet, what the point charge is, or what the distance is. And so we have a point charge. I don't know if it's positive or negative, but we have a point charge, and we're concerned about the electric field at a radius r. And so what they're saying is, what happens if I double that? What happens if I double that?
If you double Q or double?
Double the radius or the distance. Okay. So I don't know if this is a positive or a negative charge yet. I suspect they'll give us some numbers in a second. So right now they just want to know what happens if I double the radius. What does that mean? Well, then that means that I'm going to put E sub x2 is equal to KQ all over 2 times R, because that would be doubling the radius, which would be squared, which would be KQ 4R squared. And so essentially, the ratio between the two, it would be 1/4 the strength. So what we would say is that when you double the distance R, the electric field is 1/4. Okay? Does that make sense? And that's just, and I think the options were A, it increases, B, it decreases, and C, it stays the same. Well, 1/4 times, if we call this E naught or E or whatever you want to call it, it's 1/4 times E naught, right? So the answer would be decrease. So that's part A of this thing. So the second part of this question is, all right, if the original electric field due to the charge is 1.0 times 10 to the negative 4, what is the magnitude of the new electric field at twice the distance of the charge? If they're saying this whole thing was 1 times 10 to the negative 4 Newton coulombs, what would happen if I doubled the distance? Well, it'd just be 1/4 of that. And so in order to get, in other words, I'm gonna take whatever this is and multiply it by 1/4. So let me think of a better way to write that. So the energy or electric field is equal to 1/4 times what the original electric field is, which is equal to 1/4 times the 1 times 10 to the negative 4 Newton coulombs, right? And it should be 2.5 times 2.5 times 10 to the negative 5 Newton coulombs. Does that make sense? So by doubling the distance, you reduce the electric field by 1/4, or multiply it by 1/4.